All right, let's dive into a massive question, one with some potentially galaxy-sized answers. Could mining asteroids actually solve our biggest resource problems right here on Earth? Well, the whole story really starts with one simple idea. I want you to just picture for a second those old gold rushes from the history books. You know, the high stakes, the wild frontiers, the promise of just unimaginable wealth. Okay, now what if I told you that the next great rush for riches, it's not going to be happening here on Earth at all?
See, it all boils down to this. Here on our home planet, the most critical stuff we need to build everything, well, it's limited. We have a finite supply. But right above our heads, floating in space, the solar system is basically a cosmic treasure trove. We're talking a nearly infinite bounty of the exact same materials.
And that brings us to the really exciting part, the dream. The incredible promise of what's actually out there. This is the utopian vision, right? This is the reason why billions and billions of dollars are already pouring into this idea. You know, when we think about asteroids, we usually just picture these dead, boring space rocks. But that's not the real story. So many of them are more like flying treasure chests, just packed with iron, nickel, platinum, and, get this, even water ice. These are the literal building blocks for industry on Earth and for survival out in space. Just let this number sink in for a minute. $20 trillion. And that's not for the whole asteroid belt. That's the estimated value of the platinum locked inside one single asteroid. That's a number that just dwarfs the economies of most countries on Earth. It makes the whole crazy idea, well, kind of irresistible. And listen, it's not just about the flashy, expensive stuff. A typical resource-rich asteroid is mostly made of industrial-grade iron and nickel. But look at that slice, 15% water. In space, water is basically the new gold. You can drink it, you can grow food with it, or you can split it into hydrogen and oxygen, and bam, you've got rocket fuel.
So this all points to a much, much bigger picture. This is about way more than just money. Imagine a future where we're no longer fighting over resources on Earth. A future where we can build massive structures in orbit, using materials we mined right there in space, opening up the entire solar system for us to explore. That is the promise.
But, and this is a big but, if it were that easy, we'd be doing it already. So let's flip the coin and look at the other side of this equation. The absolutely monumental challenges that are standing in the way. The scale of this dream is, well, literally astronomical. And every single piece of it, from the basic physics of space travel to the financial models to the raw engineering, is pushing the absolute limits of what we can even do. Okay, so here's a simplified look at what a mission would actually have to do. First, you got to find the perfect asteroid out of millions of them. Then, you'll launch a mission to catch up with it millions of miles from home. Then, you have to somehow grab onto a spinning, tumbling rock in zero gravity, mine it, process all that ore in space, and then, finally, bring the valuable stuff all the way back. Simple, right? And the financial risk? I mean, it's hard to even wrap your head around it. The upfront cost for the research and the rocket launches is just massive. We're talking billions, maybe tens of billions of dollars. And yeah, the potential payoff is off the charts, but the investment you have to make just for a shot at that payoff is staggering. This whole thing isn't just one big problem. No, it's 1,000 smaller, insanely complex problems all rolled into one. Like, how do you drill into a rock when there's no down? How do you manage a supply chain that stretches across 100 million miles of empty space? These are the real-deal engineering questions people are trying to solve right now. But okay, let's just pretend for a second that we solve all the technical problems. A huge question still hangs over everything. Who actually makes the rules out in this new frontier? This is where that whole gold rush analogy gets really interesting. This right here is the original rule book for space, the Outer Space Treaty of 1967. It basically says that space belongs to everyone, to all of humanity. And look, that's a beautiful idea, but it was written way, way before anyone was seriously thinking about a private company mining an asteroid for profit. There's this legal idea at the heart of it all called res communis. It's just Latin for common property. Think about it like the high seas. No single country can own the middle of the Pacific Ocean, right? Well, in the same way, no one can just plant a flag on an asteroid and say, this is mine. It's supposed to be for everyone. And that leads us to the billion-dollar or, maybe the trillion-dollar legal question. Everyone agrees you can't own the asteroid itself. But if a company spends billions of dollars to go there, to dig out platinum and bring it back home, do they own that platinum? So what we're seeing now is this huge legal tug-of-war. On one side, you've got that international treaty saying space is for everybody. But on the other side, you've got countries like the US passing their own laws, like the Space Act, that explicitly say, yeah, our citizens can own and sell whatever they pull out of an asteroid. It's this classic showdown between an international commons and private commercial interests.
So with all of this on the table, the unbelievable promise, and these just monumental hurdles, where does that leave us? Is asteroid mining just some cool sci-fi daydream, or is it actually the future?
So let's just break it down one last time. The promise is a post-scarcity future, wealth beyond our wildest dreams, and humanity finally moving out into the solar system. The reality? Massive costs, a ton of unsolved technology, and a legal situation that is, to be honest, total chaos.
And that is why the gold rush analogy is just so perfect. This is the definition of a high-stakes gamble. Most of the people and companies who try this are probably going to fail, losing fortunes along the way. But the first ones who actually succeed, who crack this problem, they won't just get rich. They will fundamentally change the entire course of human history. Which really just leaves us with one last thing to think about. We're always wondering who the world's first trillionaire is going to be. But maybe the better question isn't who, but where. Will they make their fortune here on this pale blue dot, or out there in the cold, dark, and unimaginably rich final frontier?